Good morning. Today our new class is working of direct coupled amplifier and comparison of different types of couplings and also need for power amplifiers. These topics one by one discussing now. Okay. Next, recap of this presentation on recap of this presentation in previous class, working of two-stage transformer coupled amplifier and also frequency response of two-stage transformer coupled amplifier are completed. Okay. So in previous class we discussed about working of two-stage transformer coupled amplifier and frequency response of two-stage transformer coupled amplifiers are completed. Okay. Next, objectives of this presentation: on completion of this period, you would be able to understand the working of direct coupled amplifier. You would be able to understand the working of direct coupled amplifier. Next, comparison of different types of couplings. Comparison of different types of couplings and need for power amplifiers and summary. So, these topics one by one discussing now. First of all, the first topic is working of direct coupled amplifier. Working of direct coupled amplifier. So why we use direct coupled amplifier? So the direct coupled amplifier shoots well for very low frequency applications. Very low frequency application. So this direct coupled amplifier is suitable for very low frequency application. Very low frequency means is less than 10 hertz. Is less than 10 hertz frequency. Okay, the two-stage direct coupled amplifiers used to amplify very low frequency signals. So the two-stage direct coupled amplifier is used to amplify very low frequency signals. Okay, the signal frequency is below 10 Hz. The coupling capacitor, bypass capacitor and transformers are not used because the electrical size of these components become very large at these frequencies. Okay, that's why. So here there is no use of coupling capacitors, bypass capacitors and also transformers. Okay, see this figure. So this is the figure of two-stage direct coupled amplifier. See this figure. This is the figure of two-stage direct coupled amplifier. So this is the circuit of two-stage direct coupled amplifier. In this circuit, observe this circuit, the output of first transistor is directly connected to the input of second transistor. The output of first transistor is directly connected to the input of second transistor. Okay, observe this only by using wire. So one single wire. Okay, so we can connect output of first transistor to the input of second transistor. This is the construction of two-stage direct coupled amplifier. Next, so then goes to operation or working principle. Operation or working principle. So here observe this: R1 R2 forms a potential divider or voltage divider bias or self bias. RE is the emitter resistor. There is no bypass capacitor here. Okay, so first of all, the input signal is nothing but Vi. This is weak signal. This input weak signal is applied to the base of transistor T1. Applied to the base of transistor T1. This signal is amplified by the first stage. The amplified output is obtained across the collector load resistor RC of transistor T1. Okay, so I repeat this point again. The input weak signal is applied to the base of transistor T1. This signal is amplified by the first stage. The amplified output is obtained. across the collector load RC of transistor T1. Okay, similarly the signal is given to the base of the second transistor T2. So this signal, this amplified output signal of first stage, this amplified output signal of first stage is given to the base of second transistor T2, and amplified output is obtained across its collector load of second stage. Okay, so next, in this way direct coupled amplifier raises the strength of weak signal. In this way the direct coupled amplifier raises the strength of weak signal. This is nothing but operation. I repeat operation once again. First of all, the input weak signal is applied to the base of transistor T1 at first stage. So this transistor to amplify the signal. So that's why the signal is amplified by the first stage. This amplified output signal is obtained across the load collector RC of transistor T1. Okay, so next again the amplified signal, the amplified output signal of first stage is given to the base of second transistor T2, and this transistor also amplifies the signal. So that's why the amplified output is obtained across its collector load at the second stage. In this way direct coupled amplifier raises the strength of weak signal. Okay, so this is the operation and working principle of two stage direct coupled amplifier. Two stage direct coupled amplifier. Okay, so next then goes to advantages. Advantages of direct coupled amplifier. Advantages of direct coupled amplifier. Advantages. The first advantage of direct coupled amplifier is nothing but the circuit arrangement is simple because of minimum use of resistors. Only here resistors used. Okay, that's why the minimum use of resistors are used in this circuit. Then circuit arrangement is simple. Next advantage is nothing but the circuit has low cost because of the absence of expensive coupling devices. Expensive coupling devices means bypass capacitor, coupling capacitor, transformers also. Okay, that's why the circuit cost is very low. This is another advantage of direct coupled amplifier. Okay, next then goes to disadvantages. Disadvantages of direct coupled amplifier. So it cannot be used for amplifying high frequencies because it is used for only very low frequency, that means is less than 10 Hz of frequency signal. Okay, that is one disadvantage of direct coupled amplifier. Second disadvantage of direct coupled amplifier is nothing but the operating point is shifted due to temperature variations. The operating point is shifted due to temperature variations. Okay, so the output is exactly obtained at the center of the operating point in active region, but this operating point goes to near to saturation region or goes to near to cutoff region. So then operating point changes, then temperature due to the temperature variations. That's why output signal is not formed exactly. Okay, so this is nothing but disadvantages of direct coupled amplifier. Okay, next applications. Applications of direct coupled amplifier. Applications of direct coupled amplifier. So these are used to amplify low frequency signals. For example, amplifying photoelectric current, thermocouple current, etc. So these are the uses or applications of direct coupled amplifier. Okay, so from this advantages, disadvantages, applications, this topic is totally completed. Okay, next topic is comparison of different types of couplings. Comparison of different types of couplings. Comparison of different types of couplings. So different types couplings are mainly three categories: RC coupling, two-stage RC coupling, two-stage transformer coupling, two-stage direct coupling. Okay, so first one, so particular frequency response. By using frequency response, excellent frequency response in the audio frequency range in RC coupling. So what about transformer coupling frequency response? It is poor. So what about direct coupling frequency response? In case of direct coupling, frequency response is best. Best frequency response is found. Okay. Next, second particular is nothing but cost compared to these three couplings. So cost is less in RC coupling because only resistors and capacitors are used in this circuit. That's why cost is less. So what about transformer coupling of cost? In case of transformer coupling, cost is more because here two transformers are using this circuit. Okay. So transformer cost is very high. That's why the circuit cost is more. Next, direct coupling. So direct coupling cost is least because only minimum number of resistors are used. There is no use in bypass capacitors, coupling capacitors and transformers also. Okay. Next particular is nothing but space and weight. Space and weight. So in case of RC coupling, the circuit space and weight is less. In case of transformer coupling, so space and weight of circuit is more. In case of direct coupling, the least space and weight is required in direct coupling because circuit is simple. Okay. Next comparison. Next particular is nothing but impedance. Next particular is nothing but impedance. So impedance is not good for RC coupling. So next, impedance is excellent in transformer coupling. Impedance is good in direct coupling. Okay. So and next particular, that is the last particular, use of amplification. Use of amplification. RC coupling is used for voltage amplification. Transformer coupling is used for power amplification. And direct coupling is used for amplifying extremely low frequencies. Amplifying extremely low frequencies. Okay. So this is nothing but comparison of different types of couplings. Okay. This topic is completed. And next topic is nothing but need for power amplifiers. Need for power amplifier. In almost all electronic systems, the last stage has to be a power amplifier. In almost all electronic systems, the last stage has to be a power amplifier. For example, in a public address system, let us take one example. In case of public address system, it is the power amplifier that drives the loudspeaker. It is the power amplifier that drives the loudspeaker. When a person speaks into a microphone, the loud signals are converted into electrical signal. The loud signals are sound waves are converted by it into electrical signal. See this figure, observe this figure. So this is multi-stage voltage amplifier, then goes to loudspeaker. Input is very low voltage, that is the sound signal. Okay. So when a person speaks into a microphone, the sound waves are converted by it into electrical signal. This electrical signal is of very low voltage signal. That means a few millivolts of voltage. So this signal is fed directly, cannot drive the loudspeakers to give audible sound output. Okay. I repeat this point again. This electrical signal is of very low voltage signal. The voltage is a few millivolts. This signal is fed directly, cannot drive the loudspeakers to give audible sound output. The voltage level of this signal is first raised to sufficient high values. The voltage level of this signal is first raised to sufficiently high values, a few volts, by passing it through a multi-stage voltage amplifier. This voltage is then used to drive the power amplifier. So what is the purpose of power amplifier? It is capable of delivering power to the loudspeaker. It is capable of delivering power to the loudspeaker. Delivering power to the loudspeakers. Finally, the loudspeakers convert the electrical signal into sound signal or electrical energy into sound energy. Okay, thus a large audience can hear the speech or music from the orchestra, CD player or any other such gadgets. Okay, for example, in case of broadcast transmitters, power amplifiers capable of feeding large power to the antenna are required. For example, in case of broadcast transmitters, power amplifiers capable of feeding large power to the antenna are required. Okay, the power amplifier used in the last stage of a 1 kilowatt transmitter develops a power of 1 kilowatt. This power is fed to the antenna. The antenna then radiates the power all around in the form of electromagnetic waves or radio waves. These electromagnetic waves or radio waves are received by the receiving antenna. The signal developed in the antenna of radio receiver is very small and it cannot drive the loudspeaker directly. So it has to be amplified first by a voltage amplifier and then by a power amplifier. Thus, we find that a power amplifier is an essential part of every electronic system. Okay, I repeat this example once again. So for example, in case of broadcast transmitters, power amplifiers capable of feeding large power to the antenna are required. Okay, so the power amplifiers used in the last stage of 1 kilowatt transmitter develops a power of 1 kilowatt. This power is fed to the antenna. The antenna then radiates the power. The antenna then radiates the power all around in the form of electromagnetic waves. Or radio waves. These waves are received by the receiving antenna. The signal developed in the antenna of radio receiver is very small and it cannot drive the loudspeaker directly. It has to be amplified first by a voltage amplifier and then by a power amplifier. Thus, we find that a power amplifier is an essential part of every electronic system. Okay, so this is nothing but need for power amplifiers. Okay, these three topics are completed. And next, summary of this presentation, we have seen working of direct coupled amplifier and comparison of different types of couplings and need for power amplifiers. These topics are completed. Okay, next, frequently asked questions may be asked. The first question is frequently asked questions may be asked. The first question is, explain the principle of operation of direct coupled amplifier with circuit diagram. This question may also be asked. Draw the circuit of two-stage direct coupled amplifier. Okay, and next question, second question, list the applications of direct coupled amplifiers. Okay, so and third question may be asked. State the need for a power amplifiers. Okay, this question may also be asked. So draw the figure of power amplifier. Draw the circuit diagram of power amplifier. So or also may be asked. So write one example and circuit diagram of power amplifier. So different questions may be asked. And last question is, Compare different types of coupling. Compare different types of coupling. Okay. This is nothing but these are the different questions. Very important questions. Prepare well. Okay. These topics are very important topics. Okay. Thank you.